the last lecture, we mined two books for insights into where discoveries and productive ideas come from. The books were Discovering, published in 1989 and written by immunologist Robert Root Bernstein, and Where Good Ideas Come From, published in 2010 and written by Stephen Johnson. We concentrated on the mental preparation, mindsets, and kinds of exploratory action that make discoveries and innovations more likely to happen. This time, we're going to pull insights from these two books into the nature of the networks, communities, economic factors, and intellectual cultures that foster creativity and discovery. Several clues point to the importance of these societal level factors, both for generating new ideas and getting them recognized and developed. The biggest clue may not be the most obvious. Despite the commonplace legends of the first discoverer of a scientific law or creator of a new artistic style, many discoveries and innovations actually are made simultaneously by several individuals or groups. The sociologist Robert Merton found that the majority of scientific discoveries he investigated were multiple, in the sense that several people recorded the same idea at nearly the same time, even though often just one person ended up with credit as its discoverer. In Discovering, we can read that several researchers investigated the first law of thermodynamics within a few years of one another, and that at least 3 laboratories independently isolated peptide hormones from the brain within a few months of one another. Good Ideas cites an earlier study in the 1920s by William Ogburn and Dorothy Thomas, who accumulated 148 accounts of simultaneous discoveries. Their survey so closely resembled a standard catalog of the history of great discoveries that they and others speculated that such discoveries are high probability events. If Joseph Priestley hadn't isolated oxygen in 1772, Carl Scheele would have done in 1774. If Albert Einstein hadn't formulated the special and general relativity theories in the first 2 decades of the 20th century, then Henri Poincaré, Hermann Minkowski, or several others probably would have. So what makes discoveries like these so likely to happen in multiple places at the same time? 2 factors appear in all these cases. First, there's a network of people with expertise in the area who are discussing the relevant ideas, arguing with each other, but not attacking one another personally. Second, various technical and practical resources must be available to be used in exploring the ideas. As Good Ideas points out, Priestley and Scheele needed the concepts that air was worthy of study, and more important, that it could be composed of separate gases. Both ideas were new at the time. More practically, they needed the scales that could measure the small effects of oxidation. Consider the quandary of the 11th century schoolmen debating whether heat and cold are separate or identical properties without the availability of even crude thermometers, or a theory that could distinguish between heat and temperature. I sometimes remind my students that in many areas of psychology, we're no further advanced than those 11th century scholars. We have no genuine thermometers or yardsticks of thought or emotion. Now let's turn to the question of where and when discoveries are likely to be made. Kevin Dunbar, a McGill University psychologist, set up video cameras in 4 leading molecular biology labs and recorded what scientists did there. Dunbar found that most of the important new scientific ideas emerged during lab meetings, where work in progress was being discussed. They seldom occurred to scientists when they were alone. He found that group interactions challenged researchers' interpretations of their own work, offering new contexts or analogies and inputs from other specialities. Dunbar's findings agree with earlier observations by the philosopher Donald T. Campbell, who claimed that rapid progress and innovation in a discipline requires constructive arguments and debates among the people working therein. Too much agreement among researchers results in complacency and stagnation. Worse still, it can result in arrogance. Arguments that descend into personal attacks, on the other hand, can cease dialogue altogether. Good Ideas takes up Arthur Koestler's observation that many creative ideas are the result of cross-fertilization from different disciplines, and identifies an environment in which such cross-fertilization is likely to occur. It's a uniquely urban place, the coffee house. An archetypal version is the 1920s Paris or New York cafe, where artists, writers, actors, architects, and scholars gather together in meetings, discussions, and performances. Discovering arrives at a similar viewpoint from a different route, namely by documenting how the most innovative scientists usually had multidisciplinary backgrounds, networks, and interests that they sustained throughout their careers. Discovering adds the observation that the exceptional scientists who remain creative past middle age changed fields consistently rather than remaining in the same specialty for a lifetime. Discovering and good ideas both have things to say about working environments and incentives that generate creativity and those that stifle it. Discovering points out that many scholars, scientists, and artists have observed that the surest way to kill creativity is to make the would-be creator's salary depend on it. If they had their way, the most creative people would prefer to be somewhat underemployed, with enough money to be reasonably comfortable and plenty of leisure time to engage in the creative activities that they love. Because they don't know what they're going to find or how they are going to find it, explorers and discoverers have difficulties with conventional, accountability-driven, and risk-averse regimes comprising most governmental and private funding for research or innovation. They seem to operate largely outside a profit-oriented market setup. Explorers and discoverers also have problems with the typical corporate insistence on intellectual property ownership or the governmental counterpart of secrecy. They usually insist on sharing their ideas with anybody who will listen. Good Ideas develops an ad hoc but instructive classification of innovations and discoveries, ranging from the development of Braille to the discovery of mitochondria in a 2x2 scheme, those taking place in a market versus a non-market setting, and the creative process being driven by an individual versus a network of innovators. The least populated quadrant is the individual working in a market-driven environment. The most populated quadrants are the networks, operating both within and outside market forces. The archetype example of this latter environment, of course, is the ideal university. However, many modern universities have tended to become ensnared in bureaucratic regulation, and some corporate leaders have figured out how to facilitate the emergence of non-market networks of innovators within their own companies. There's a natural tension between the market and non-market ideals of creative networks. The market version usually requires at least some means to concealing new ideas and preventing their theft by competitors. Otherwise, innovators operating in markets cannot profit from their own innovations. However, sequestering ideas also limits exaptation of related opportunities for additional innovation or recycling of ideas. The non-market network maximizes the spread of ideas through the network, but limits the extent to which any individuals or subnetwork can gain an advantage over any other. What is intriguing about the non-market open network's prolific productivity is the seeming absence of a profit motive. We now know from, among other grand social experiments, the failure of centralized state socialism, that command economies do not sustain innovation. We have also abundant evidence that large-scale centralized bureaucracies are toxic for creativity. However, the usual explanation for both of these failures, that they lack a profit incentive, does not account for the successes of the non-market open network. Nor does any attempt to save the profit motive explanation, such as claiming that open network innovators' profit is respect from their peers. From an extrinsic reward standpoint, having your foundational paper cited several hundred times is a very paltry profit when compared with reaping billions of dollars from your patented or copyrighted intellectual property. Instead, the most promising explanation of the open network's effectiveness is that intrinsic rewards are very important to at least some people, so much so that they strongly prefer to participate in non-market open networks rather than market-driven ones. Moreover, they are willing to consciously forego opportunities for extrinsic rewards if taking up those opportunities would require sacrificing the work that they find intrinsically rewarding. And that is the answer to the hoary question that so many artists, scientists, scholars, musicians, and academics are asked. If you're so smart, why aren't you rich?